Okay, hi everyone. So we're done with Venn diagrams now. We're going to go back to some probability that we did before half term, again to slightly more detail. So we're going back to probability trees, but we are going to be getting into somewhere the probabilities change each sort of level of the tree. So what we saw before half term, we looked at independent events, and we saw that if A and B are independent, so the outcome of one doesn't affect the outcome of the other, then the probability of A and B happening was the probability of A times the probability of B. And what this meant was that we could make probability trees, so having event A here and then event B on the second branch. And to work out the probability of something happening, say here, we would multiply this branch and this branch, and that would give us the overall probability of this outcome. So we saw that you can multiply down the branches to work out the final outcome of events A and B happening. So what we're going to look at today is what happens when the numbers change. So for example, if you were taking out balls from a bag, if you were to not put them back in between each go, obviously the number would change each time of how many there are in the bag. So we're going to go through this example and kind of work out how that changes the probability. So the question here is, given that there's 5 red balls and 2 black balls, what is the probability that after 2 picks we have a red and a black? So let's start off with what we know to start with. So we know that there's 5 red and 2 black to start. So that means there's 7 in total. So we've got 5 out of 7 is the probability of getting a red, 2 out of 7 as the probability of getting a black. So now that we've got those probabilities, we can start thinking what would happen on the second pick. So on the second pick, we've got 1 less. So let's look at this top branch. So the first one we picked a red. So there's now only 4 red ones in the bag. And there's also only 6 in total. So in that case, the probability of getting a red the second time would be 4 out of 6, or 2/3. So we can see that the probability's changed. The number it's out of has changed, and the number of red ones we have has changed. So looking at the one below that, the number of black ones in the bag didn't change because we've got a red one. So there's still 2 black ones in the bag. But the total has changed to 6. So the probability of that would be 2 out of 6. And we can see that on these branches, the probability still adds up to 1. So 4/6 add 2/6 is still 1. That is because you've still got to either pick a red or a black. So on that branch, the probability would still have to add to 1. So that's a really useful check to check that you've done it right. So let's look at the bottom branch now. So on this branch we picked a black one the first time. So that means that there's only 1 black one left, and there's still 5 red ones. So that means that out of the 6, there's 5 red, so that'd be 5/6 red and 1/6 black on that one. So we can see that the probabilities in the second one are all out of 6 because there's 1 less ball, and the numerator will depend on what we picked the first time. So you kind of have to think out what is the case this time. So let's look at another example. So what is the probability that after 2 picks we have 1 red and 1 black one? So what we have to do then is look at the ways that end up with 1 red and 1 black. So either we could pick a red one first and then a black one, or we could pick a black one first and then a red one. And to work out the probability of those 2 events, we need to multiply down the branches. So let's start off by doing the first branch, red and then black. So on that one, the probability of getting a red was 5/7, and the probability then of getting a black was 2/6. So we need to multiply those together, and we end up with 5/21. So that's after simplifying. Then on this other branch, the one where we go black and then red, we've got 2/7 times 5/6. And the probability of that is 5/21 as well. So then the probability of getting a red and a black, we've got 2 possible ways of doing that, so we need to add together those 2 probabilities. So we've got 2 lots of 5/21, so we do 5/21 and 5/21, which gives us 10/21, and we can't simplify that down at all. So the probability of getting a red and a black in either order is 10/21. So to summarise what we've seen so far, there's two different sorts of tree diagram questions. There's the sort we did before half term, the with replacement. So with these ones, they put the item back before they choose another. So with this one, the amount of items doesn't change. So in your tree diagram, the denominator would be the same. There's then this one we've just looked at today without replacement. So in this one, it'd be like you're taking something out of the bag and not put it back. So in that case, the number of items in the bag decreases by 1. And also the number of items of that type decreases by 1 as well. So it's really important that you know the difference between these two because it'll give you different answers. If the question doesn't specify which, so if it just says something like you pick 2 out of the bag, assume that you don't replace it. Because if you're taking 2 out, that would be without putting 1 back in. So the default would be without replacement. Only if it says that it's put back or it's replaced would it be this top one. Okay, so that's the new content for today's lesson. So if you want to go and start the task, that's completely fine. I'm going to go through another couple of examples just to kind of drive home how we pick between whether it's with or without replacement. But from this section onwards, it is stuff we've seen before. If you do want to skip ahead to the end of the video though, there is an example of one that was trending on Twitter a while ago. It's a GCSE question. So if you want to skip ahead to that one, it's the one about Hannah and the sweets, if you want to skip ahead. But if you want to just start the task, that's also fine. Okay, so on this one we've got a bag of sweets, 3 blue and 7 red. I pick 1 sweet without looking, eat it, and then pick out a second sweet. What is the probability that I've eaten 1 blue and 1 red? So the first thing to decide is this a with or without replacement? So we can see that in the question it says we've eaten it and that we eat the second sweet as well. So with this, if we've eaten it, obviously we're not putting it back in the bag. So with this one, this is without replacement. So we've got our sweet one, we've got red and blue, and our probability is there. With sweet 2, because we've not replaced it, our denominator, so the total number of sweets, is going to decrease by 1. So we've got our options there, and they're out of 9 now, and we can see that the number of red sweets has decreased by 1. Our other option, so again, see that we've 1 blue sweet down, so it's out of 9 now, and it's the blue sweets that have decreased by 1. So what is the probability? 1 blue and 1 red. So we've got, so we work out our probabilities by going down the branches and multiplying together. So probability of red and blue, so I've got either probability red blue or probability blue red, and it's 21 out of 90 for both of them. And so because it's an or, you could do it either way. We're going to add those probabilities. So we've got 21 90ths or 21 90ths. So overall we'd have 42 90ths as our probability of having one of each. And we can simplify it down to 7 15ths. So that's one without replacement. Okay, so just going to do one last example. So this next example was trending on Twitter a while ago. Basically it was in a GCSE paper. It was worded quite badly, so there was kind of a setup to a question and suddenly some algebra came out of nowhere. So a lot of people found it quite funny, kind of the setup of it. So I'll go through that one as well. If you want to have a go, pause the video, have a go at it, see how you would have done in the GCSE paper. If you want to just watch me going through it, that is fine as well. And if you want to go start a task, that is also fine. So there's n sweets in a bag, 6 of the sweets are orange and the rest of the sweets are yellow. Hannah takes at random a sweet from the bag, she eats the sweet, and Hannah then takes at random another sweet and eats that one. The probability that we get 2 orange sweets is 1/3. Show that n squared minus n minus 90 equals 0. So you don't need to, this is definitely a little bit beyond what we need at the moment, so if you don't know how to do this, don't worry too much. But if you want to have a go, feel free, but as I say, it's a little bit beyond what we need at the moment. But let's see how we do it. So we've got n sweets in the bag and 6 are orange. So we've got orange, so there's 6 of them orange, it is out of n sweets in the bag, so 6 over n. Then we've got yellow, so because there's only 2 options, they've got to add up to 1, so the probability of getting yellow is going to be 1 minus 6 over n. The other way we could write this would be n minus 6 over n, because we've got 6 sweets that are orange, which means we've got n minus 6 which are yellow, and it's out of n. So we've got n minus 6 over n is our probability of getting yellow, 6 over n is our probability of getting orange. Okay, so then Hannah has eaten the sweet. So this is without replacement, so that means our denominator is going to decrease. So to get orange again, there's now only 5 orange sweets. So we've got 5, and it's out of n minus 1. And so the probability of getting a yellow is still n minus 6 sweets. There's now n minus 1 sweets in total. So it's n minus 6 yellow sweets, but there's only n minus 1 in total. So now I go into the yellow ones. So we've got orange. So now there's still 6 orange sweets, that'll be 6. And it is out of n minus 1 now. And yellow. So we had n minus 6, we've now got n minus 7. And we've got a total of n minus 1. So we've got our probabilities of each branch. We can now see what we need to work out. So we're told this is our key information. The probability that we get 2 orange sweets is 1/3. So that means if we go down this branch and down this branch, the probability would be 1/3. So let's calculate then what we've got in terms of n. So if we've got 6 over n and we times it by 5 over n minus 1, so that's going down this branch, 6 over n, and then down this branch, 5 over n minus 1, and that equals 1/3. So we can start to solve this now. So when we times in fractions, we times together the denominators and we times together the numerators. So we've got 30 over n minus 1, and that equals 1/3. So what we've got here, we've got something in terms of n equals 1/3. So now if we times both sides by 3, and that'll get rid of the third over this side. So times in both sides by 3, so we've got 90 over n minus 1. So we only times the numerator when we times them by 3, and that equals 1. And then we're going to try and get rid of this denominator now, so we're going to times both sides by n minus 1. So it's at this point, this is definitely beyond what we need. So if you're struggling a bit, don't worry. So we end up with 90 equals n minus 1. So now if we expand out this side, so the right hand side, so we've got 90 equals n squared minus n. And if we take 90 from both sides, we end up with 0 equals n squared minus n minus 90. So we've got what we wanted to show here. We've got 0 equals n squared minus n minus 90. So this is kind of, you can see why it seems very different to what we've seen before. It's because of the fact that the branches are algebraic. So this is definitely kind of year 10, year 11 content. So if you are struggling, really don't worry. Part 2 of the question, we've got n squared minus n minus 90 equals 0. It wants us to find the value of n. So we just need to factorise this quadratic. So we've got numbers that times together to make minus 90, add together to make minus 1. So we end up with n minus 10, n plus 9 equals 0. So then either n equals 10, n equals minus 9. So we can't have a negative number of sweets in the bag. So that tells us n is our number of sweets in the bag. So n equals 10. That's our final answer for that one. Okay, so definitely a bit of a tough one to finish with. You can see why it made the news. The jump between Hannah eating sweets to suddenly an algebraic question is quite a big jump. So the ones we see won't be as hard as that, but in GCSE papers they are swaying towards more problem solving ones like this, so just something to be a bit aware of. If you just work it out with a tree diagram like normal, you will be able to get there. It'll just be quite a bit harder. So moving on to today's task, there's a Dr. Frost element, and I've also put some extension questions on the Firefly one, so if you do finish the Dr. Frost one, you've still got plenty of time left. Do have a go at some of them because they're a little bit harder.